Hello and welcome to the in-series, in-parallel virtual lab tutorial. What I have set up here are a couple of circuits that you're going to be making in lab. On the left are 3 resistors in parallel. On the right, 3 resistors in series. And what we're going to be covering right now is some basic calculations that you're probably going to want to do. On the left here, let's say we wanted to calculate the current of this wire right here, the current running through this wire. Now, notice how the electrons are moving much slower here than they are out here, so it's likely that this current is going to be slower. So first, we need a couple of things. We need the total current, which is 2.70 amps, and we need the resistance, which is 10 ohms. So the calculation we're going to start doing is, first, we're going to find the Siemens of that resistor, which is 1 over R, so that's going to be 1 over 10. Now, we're going to take this 1 over 10, just like we did in class today, and multiply it by the total current, which is 2.70 amps, and then divided by the total Siemens of all the resistors. So it's 10, 10, and 10, so that is 1/10, 1/10, and 1/10, which adds up to 3/10. And remember, the symbol for Siemens is an upside down ohm, or omega. So we have 3/10 down here, and these tenths are going to go ahead and cancel out, so you're actually going to have 2.70 divided by 3, and that's going to give us a total current of 0.9 amps. And if we go back here and use the non-contact ammeter, we'll see that that is indeed the case, 0.90 amps. Now, a calculation you're going to want to do with the in-series one is calculating the resistance of one of the resistors, and these are just samples. You may or may not be doing these in lab. So the first thing we're going to want is the current, because we're going to be using Ohm's law. And then let's go ahead and get the voltage difference of just one of these resistors, since I've actually set these up so that all these resistors are equal. The voltage difference is 3 volts, and the current is 0.30 amps. So remember that Ohm's law is V equals IR. So we're going to take the voltage, which is 3, and the current, which is 0.3 amps, multiplied by R. Now to find the resistance, 3 divided by 0.3, so R is going to be 10 ohms. And if we check this out here, we can see that that is indeed the case for all of these.